Welcome to the Cool Tools Show. I'm Mark Frauenfelder, Editor-in-Chief of Cool Tools, a website of tool recommendations written by our readers. You can find us at cool-tools.org. I'm joined by my co-host, Kevin Kelly, founder of Cool Tools. Hey, Kevin.
Hey, it's great to be here.
In each episode of the Cool Tools Show, Kevin and I talk to a guest about some of his or her favorite uncommon and uncommonly good tools they think others should know about. Our guest this week is Theodore Gray. Theodore is the co-founder of Wolfram Research, architect of the Mathematica Notebook System, founder of Touch Press, the BAFTA award-winning director of Disney Animated, which was the iPad App of the Year in 2013, author of the million-selling trilogy The Elements, Molecules, and Reactions, and creator of a unique line of transparent mechanical models he calls Mechanical GIFs. By the way, I wasn't able to participate in this episode, so my co-host Kevin had full hosting duties. Take it away, Kevin.
Hello, Theo. It's great to have you back, and we're looking forward to some more of your fantastic tools. Tell me about one of your favorite tools recently. I hear it has to do with the camera.
Yeah, well, so the books that I write are coffee table photo books. They're full of pictures. So, we have a lot of cameras. We've had multiple generations of cameras. A long time they were all Canon lenses, and we've switched to, various other cameras. It seems like, in the history of cameras, it used to be that the camera body was really almost irrelevant, because what mattered was the lens. You got to have good glass, as they say, or you're not going to get a good picture, and the film. And the body was just the thing that held the film, and maybe it had some kind of features, but really it didn't make that much difference. And then digital cameras came around, and suddenly it made a huge difference, because the quality of the sensors was, at first sort of barely adequate, and then, constantly you could want a better sensor, and you'd want to get a better body, and the bodies became expensive because a lot of the important stuff was in the camera body. But now it's kind of gotten to the point where the sensors are so good, they're so high resolution, they're so sensitive, they're so low noise, that it's back to almost any camera body is fine, except for the most extreme demands of super low light or super high speed or something. Really the camera is fine, and it's back to the lens matters. And so we now use a variety of different brands of camera body and adapters to the Canon lenses, because those are very expensive. But the other thing that's happened is that, the old saying that the best camera is the one that you have with you, which goes along with the saying, F8 and be there being the most important, categories for getting a good shot, is the fact that cell phone cameras are now, they're ridiculously good. And I've been a holdout. So I refused for years to upgrade past an iPhone 6, because, what do you mean there's no headphone jack? That's insane. I will not give Apple 1 red cent until they put the headphone jack back. But the thing that finally pushed me over the limit ultimately was, first of all, it's hard to get a working iPhone 6 anymore. And the camera in the iPhone 11 Pro, I think, has sort of now crossed the threshold where I feel like I can comfortably go out into the field, go on a trip. I'm going to, fly somewhere, and just not take a camera.
No, is this the phone that has 3 cameras basically in the back?
It's like razor blades. They're just, they're going to go up to 5 or something, and
Right.
call it a day.
So there's 3 different lenses and 3 different sensors in the back of the phone.
Yeah, and it looks ridiculous, and it creeps people out. Some people anyway. But it's just it's good enough. We can, I feel confident that if, as long as it's not a technical situation where, there's something I need to super zoom or whatever, these are going to be pictures that we can print in the book, even full page probably. They're just good.
Right. So actually, are you going to actually start using that phone to photograph some of the images for your book?
Well, I mean, we wouldn't use it in the studio. In the studio, you have a tripod and you have a big lens and you have all kinds of lights and everything. But I'm talking about, I'm just, and I try to do this as much as I can. I'm on a trip somewhere, and oh, there's a cool thing. Like I'm going to start working on a book about tools as it happens fairly soon. And I'm constantly seeing tools just out in the wild somewhere. And, you know, in the past, I would be carrying around a camera because if you see some cool thing and you want to put it in your book, you better have a good enough picture of it. Um, unless I'm prepared to actually buy the tool and carry it home with me. Uh, I just need to have something that's good enough. It doesn't have to be perfect. Doesn't have to be some super expensive, like a Hasselblad, whatever. But it has to be good enough. And I think the current generation of cell phone cameras has sort of crossed that threshold, which is really cool because it's one less thing to carry around. I think it crossed that threshold for most people a long time ago because for just taking pictures that you're going to have, they've been great for quite a while.
But this is more like you're saying this is at the level of professional quality at this point.
Yeah, which of course Apple's been advertising that for a couple of years now that we can make a movie. But
and those three lenses, could you just briefly describe what you get for three lenses and how easy is it to switch between the three?
You don't switch; it does it for you. It's not just the lenses. They have this really clever software where you just pinch in and out. Like you can zoom in and out, and it's somehow magically blending the images from the three cameras. And seems to do a really good job of it. I think the biggest, I don't know, since my previous phone was an iPhone 6, I missed the innovation of the previous, 5 upgrades or whatever. But I think the big deal about this one is the wide angle is really wide angle, which is great. If you're in a museum and you've got some gigantic steam engine in front of you, cameras that haven't, the cell phones that haven't had super wide angle in the past were not adequate for that because you couldn't capture the whole thing. But it's just, extending it farther into the wide angle and farther into the telephoto to the point where you don't feel like an idiot for not having brought your camera because you did bring your camera.
And also, I know that it has really good low light sensitivity as well.
That's what blows me away because, I remember, 10 years ago, spending $1,000 on a lens whose main calling card is this just massive pool of glass, 3-inch diameter clear aperture all the way through, just to gather up light, to be able to take a good picture in relatively low light. And the sensors kept getting better, and better. And now you have this thing with this lens you can barely see, this tiny little, 1/8-inch lens or something. And yet somehow, they've gotten, in other words, it's gathering very little light. It's tiny. There's just not much light hitting it. And yet somehow the sensors have become so good. And the software, I think it's not just the sensors, but also the software that processes the images, have gotten so good that its low light performance is very respectable.
So maybe we should think of the iPhone 11 as a camera that happens to do other stuff as well.
You could put it that way. I mean, it does a lot of other cool things, but the thing that caused me to fork out the cash was the realization that this is now good enough. And all right, fine, I'll deal with the fact that it doesn't have a headphone jack. I don't like it, but
the camera without the headphone jack. Okay, so tell us about a second one of your tools that you've want to share with us.
Yeah, so the second one I picked is because I feel like one of my areas of activity was left out of my previous selection of 4 tools, and that's the whole stitching hobby of mine. I guess it's not really a hobby. We sell them. The stitching activity of my life. So we have this machine. It's a very big quilting machine. Basically, what it does is you imagine an XY plotter.
Does it have a name? Can we give this machine a name in case somebody wants one?
It is. I think it's called a Stitch Master brand.
Stitch Master, okay. And describe the physical. I mean, what does this thing look like? First of all,
so imagine that you have an XY pen plotter. Like an old school pen plotter, except instead of a pen, it has a sewing machine. And instead of being, a foot square, its working area is 8 feet square. The whole machine is more like, 10 or 11 feet square. And, what's moving around is a high-speed industrial sewing machine on an XY track. And then what you do is you stretch fabric typically like a sandwich of fabric with batting in between, the sort of puffy stuff in between. And then you just give it a file. It's a very simple, set of lists of X, Y coordinates, and tell it, stitch along this path. And just like a pen plotter, it just runs along and it stitches.
So the images, you have a bed, and then on the bed is the fabric that's going to be quilted. Now, in my mind, a sewing machine, there's two parts. There's an upper part and a lower part, and the upper part has a needle going up and down. The bottom has a bobbin receiving it.
Yeah.
And so you say it's moving. So is the bottom part also moving as well?
Yes, and that's actually that you've picked up on the central mystery of how this machine works, because you have the bobbin on the bottom, the needle on the top, and they have to be aligned within a fraction of a millimeter and timed to within fraction of a millisecond, so that the needle goes down, and then there's this thing called a hook that just they say it kisses the needle. It just sort of taps the needle on its way around and picks up the thread that's stuck in the eye at the bottom of the needle, and pulls it around the bobbin and creates a stitch. And the tolerance that is required between those two moving parts is incredibly tight. And normally a sewing machine has a big metal, like a C clamp sort of a frame with gears, either gears or a belt drive, a toothed belt that synchronizes the bobbin and the stitch and the needle. And it's a rigid single piece. So you can't do that if you want to have this thing moving at high speed on both sides of an 8-foot wide piece of cloth. And so this machine, it's actually a fly-by-wire sewing machine, as it were. There's servo motors, not stepper motors, but servo motors for the needle. One servo motor for the needle, one for the bobbin. And they're running on independent linear bearing slides with incredibly tough, thick, heavy-duty toothed belts that move them. And somehow this thing is able to stay perfectly in alignment and perfectly in sync. Its maximum speed is 2,000 stitches per minute. So let's see, 1,800 stitches per minute. I did this math. That's 30. It's a little over 30 stitches per second.
Wow.
That's fast. It is a
That
very
is
fast
fast.
machine.
Yes.
30 stitches per second. So 30 times a second, the needle goes down, the hook comes, grabs the thread, pulls it completely, forms a loop around the bobbin, whips it tight, and does it again 30 times a second while it's moving at a considerable speed, flying across the fabric here. So the next thing you have to imagine is this machine is massive. The moving part, the moving beam that is like the main axis, weighs about a ton, like a literal ton, because it's a tremendously rigid steel frame, thick steel plate, and these I don't know, 1.25 inch diameter linear bearings, slide bearings which is necessary because you need it to be absolutely rigid. So you've got one big servo motor in the back that's moving this. Maybe it's half a ton. It's like 1,000 pounds, a half a ton. I don't exaggerate here. So 1,000 pounds in motion, being slid back and forth in one direction, and then the actual sewing machine is less than that. That's moving in the Y direction.
Right. And so the total effect of all this is what you're doing is this is to quilt big quilts. Is that right?
Yeah, it's to stitch.
Right.
It's like an embroidery machine, only
Right.
huge.
Right. And so a huge, like a bedspread. So you're taking like a bed coverlet and you're going to quilt it in the whole thing in patterns of your devising, using algorithm, whatever. And so it weighs tons and costs, like, just give us some ballpark figure of what it costs.
I think the model we have was like 32,000, and I should clarify, it's actually not my machine. It is my ex-girlfriend/wife's machine. So Nina Paley is a fairly well-known and acclaimed animated filmmaker who bought this machine while we were married, and then now we're not married anymore. But the machine is still in my office because it's too big to move. It's like you can't. You have to take it apart and get a semi just to take the pieces away. So it's there, and we exist with it together. And we make quilts with it. So some of them are art quilts that she makes, and some of them are like periodic table type quilts that I make.
Okay. And so again, that we'll put in the show notes the actual link for that particular kind of quilt.
Yeah. So this it's a
quilting
machine that's I mean there are thousands of them in China. If you go to Walmart or someplace like that and you buy a quilt, just a sort of a generic off the shelf quilt, it will have been made on a machine very much like this. There's a couple of brands, but this is one that is widely used as factory production equipment.
It's Chinese made.
Yeah, it's Chinese made. They're all Chinese made. Um, then they're all exist in China. There's very few of them in the U.S., but there's a dealer in Missouri, Quilt Masters, that we went through to buy it, and they sell them here. But there's not a whole lot of demand for textile production machinery in the U.S. anymore.
So what's a third tool, Theo?
So let's see. The third one that I had was Libra Cad.
Okay.
So one of the things that I do is design acrylic models. There's these little kits. You put them together, and it's an engine or a steam engine or a lock. I have a really nice one for a combination lock, and they're made out of laser cut acrylic. And so I have to design the patterns, the shapes to cut, and it's by its very nature 2D, because that's what a laser cutter does. It cuts a two-dimensional sheet, and it's actually sort of mathematically speaking and operationally quite similar to stitching, because again, you have an XY path that it's following. But the kinds of designs that I'm doing are very different. So I needed to pick a CAD program, and AutoCAD would be the obvious choice, but it's ludicrously overpriced, and I wasn't, as a person who has been involved with selling commercial software, I felt like I probably shouldn't pirate it. So I was looking around for what's something else. It also seemed really complicated. So I found this thing called Libra Cad, which is a free open source CAD program that basically just does 2D. I think it has some kind of 3D features, but I never looked at that. And I find it endearingly simple. It's it has a lot of bugs, and I can't get the splines to work right, so I don't use splines. But I find that it's sort of exactly the right level of simplicity, so that I really don't I'm not struggling with its features all the time. It just lets me draw clean, simple 2D shapes really easily, and then put them in a laser cutter, and boom, they're there. And you can literally have a 30-second or 1 minute cycle time. You do something in the program, and there it is.
Okay, and it runs Libra Cad runs on the Mac, Windows.
Mac, yeah. I don't know if they have a Windows version, but I don't use Windows, so.
And did you ever look at things like just using SketchUp versus wouldn't that be as simple as that?
Yes, I did. I have used SketchUp, but the thing that I liked about LibraCAD is that it's like the grid is front and center. What I wanted something where specific dimensions are really easy to stick to. And I don't know, maybe SketchUp. It seems like SketchUp is more oriented towards sort of, I don't know, free form sorts of things. But I always want to have, this needs to be exactly 28 millimeters wide to match up with this other part here, or these two things need to add up to the same width. And I don't know, it's one of these things where there probably are better tools that I could be using. But this one, I tried a couple different ones, and this one just kind of, I gravitated towards it because it guided me towards making shapes that I liked through its limitations, shall we say. In other words, it's not the most powerful by any means. And like I say, splines don't even work. You'd think, it's pretty fundamental. I have to make circles instead. So all my designs are segments of circles instead of splines. That would seem like a really fatal flaw in a CAD program.
And describe what a spline is to
a
folks.
spline is like a cubic curve as opposed to a quadratic curve, and it's like every from the very beginning, Adobe Illustrator back however many decades ago that was, splines have been the fundamental tool for drawing smooth curves. You start off in a certain direction, you specify a tangent at the beginning, points it goes through, and tangent at the end, and it's all beautiful and it's smooth, and you can connect them together without kinks, and it's like it's the only sensible way of making smooth curves that link up with each other. Um, and this program screws them up. And, you know, uh, and yet somehow, you know, I'm not only okay with that, I kind of like it because it forces a certain design aesthetic. And if you look at my models, they're all circles.
And these, by the way, these models are basically acrylic, transparent, um, mechanical annotations of how machines work. So they're kind of plastic parts and gears
Yeah.
that all mesh together.
Yeah, they're designed to be stylized. The whole point was to be like a simplified diagram, like you would do in a drawing in a book, where you've left out all of the detail and the complexity and the sort of real world trouble of actually making a machine that works, and you've just illustrated schematically the fundamental aspects. I wanted to have that characteristic, but in a machine that actually works, like you can actually spin it and the things go back and forth.
Right. Okay.
So that's why I think the limitations of the program have been actually helpful. It sort of forced me to simplify.
So as an open source free version, it's worth trying out to see if it suits your particular needs if you're looking for a CAD program. So Thea, what's your fourth cool tool?
So the fourth one is stereo lithography printer.
Is this a brand? Is that a brand name?
The brand name is Anycube. Anycubic, I think is what it's called.
NEQ, like the letter NEQ?
No, like Anycube, I believe. Yeah, Anycube. It's a Chinese brand of basically Formlabs are the ones that pioneered this technology. I think sort of commercializing it. And the Formlabs, it's a resin printer, right? You have a vat, sort of a tub of liquid, and then a build plate that descends into the liquid, and then it sort of very slowly over a period of hours draws itself up out of the liquid, and the object, it's very kind of Westworld. It sort of pulls the shape up out of a vat of goo.
Right, and so that's in contradistinction to the typical vision of a 3D printer, which is hot filament, which is
Right.
melting and sending a liquid that solidifies as it builds up.
Right, it's completely different technology.
Why is this method? Why do you prefer this method?
Well, so I have filament 3D printer and used it a bunch of times, and everything looks 3D printed, right? You know what I mean? It's like it has that certain look to it. The filament 3D printers it's kind of tree rings around, and the parts are not very strong, and it's incredibly slow. And I love the idea of a 3D printer, but the actuality of filament 3D printers I've always found very disappointing, and I didn't want to use and don't use any parts in any of my kits that are printed that way. But like we were just discussing, laser printer is a fundamentally two-dimensional thing. And if you want to have a third dimension to the parts, you can't do it with a laser cutter. And that the situation was brought to a head when I decided I really want to make an internal combustion engine. And the crankshaft of an internal combustion engine is just a deeply three-dimensional object. There's just no way around it, that you need the third dimension. And so I was trying to figure out how can I make that part so I can include it in the kit. And I'm not going to 3D print it. It would not be strong enough. It would be too rough. It just wouldn't work. And so I was looking at the Formlabs, and these printers are, $5,000 or something. They're very expensive resin printers, and the resin is ridiculously expensive. And so I had rejected that a few years ago. But then I looked again earlier this year, and I discovered that there are literally $200 stereolithography printers. The one I bought, I think it was like $450 or something like that. I got like the slightly higher end of the super cheap ones. And what's happened is that, the fancy ones, the expensive ones, they use some kind of, I don't know, like a scanning UV laser. The idea is that you have this resin that's hardened by light. So you have a vat with a glass bottom, and you shine UV light up from the below, and it hardens a thin layer of resin. And then the build plate moves up just a little bit, and new resin, flows in underneath, and then you harden again, a different pattern. And the expensive ones they use, either a UV laser or a DLP, a digital light processor chip with some kind of UV light source. And it's difficult, it's optically messy, and expensive. And they're just it seemed out of reach, and the resin was too expensive. What people figured out is you can take a commodity off-the-shelf cell phone LCD panel, like you'd have on any standard phone, a Retina resolution display. You leave out the polarizers and the backlight and everything. No, I guess no. You leave in the polarizers, but you leave out the backlight, and you leave out the color. The color overlay that makes red, green, blue pixels. So you just have, something like 6 million black and white pixels, and you press that right up against the bottom of the glass of the vat, and then just shine UV LEDs up from below through the screen. And the spatial resolution of a Retina screen, times 3 of its normal resolution, because you've got 3 pixels for every ordinary pixel. You don't have the color. It's tremendously high. The dot pitch of those screens is extremely fine. And, you can build this whole thing for $200, or buy it for $200. You're building it for much less. And they work great. So, I now have a kit, an internal combustion engine kit, and a new one coming out soon, that have stereolithography printed crankshafts in them.
And again, the name of this this higher low end model is Anycube, and is there a model number that you
So it's an Anycubic, ANYCUBIC Photon S.
Okay.
Pre-Christmas sale, $389 on sale.
And that's just on Amazon or Alibaba, or where do you get them?
I got it from AliExpress, I think, but I believe they sell it
AliExpress.
through Amazon also.
And then replenishing the resin, is that you said that was expensive at one time? Is that still expensive?
Yeah, so if you buy it from Formlabs, it's, I don't know, $120 a liter or something. But you can buy, there's several suppliers. Anycubic sells their own, but they're all chemically very similar. It's like $40 a liter.
Okay.
And that works out, to I don't know, maybe 10 cents of resin for the parts that I'm making. So quite reasonable.
Uh-huh.
The thing
great.
that the fundamental difference, aside from the quality of the parts being much higher, is that with a filament printer, if you want to make 10 of the same part, it takes you not only 10 times longer, it actually takes you more than 10 times longer, because it's basically building them one at a time, but it has to travel between the parts. With this type of printer, with a stereolithography printer, if you're making 10 parts simultaneously, it makes them all at the same time. And, it takes the same length of time to make 10 of them versus one. And so you can actually grind out, a significant number.
That's really cool. Well, Theo, this is fantastic. Thank you for those great tools. And you've used some of these tools in making your latest book called How Things Work. So tell us a little bit about that book. I love it. It's fantastic. I have a copy, and it's about the inner workings of everyday machines, including things like a sewing machine.
Yes, there's one chapter which is how to make a potholder. No cheating. So I started. It took me like 2 years altogether, starting from cotton seed. So I had to, plant cotton.
Wait. So you actually made a potholder from scratch? You mean?
Yeah. Well, I mean, what does from scratch mean? So I decided that the closest that you could come to that, aside from evolving your own cotton plant, would be to start from cotton seeds. Like, I couldn't go any farther back than that. So I planted cotton seeds and I grew the cotton, and then you have to pick it and not have it die in the summer. You have to be a good farmer, which I'm not, but enough of it survived. And we picked it, and then you have to gin it. The cotton gin that everyone learns about in 5th grade. So I had to build a cotton gin to separate the fibers off, and then you have to card it, which is aligning all the fibers. Then you have to spin it into thread, and then you have to weave it, and then you have to sew it. Once you've made cloth, then you have to sew the cloth. So I did all those stages.
And so, like, how many cotton plants did you need to begin with to have enough for a potholder?
So I planted 1/40th of an acre, otherwise known as about 1,000 square feet of cotton, and I got about, I think, in the end, about 20 pounds of cleaned cotton. Which is, like, if you look up the commercial yield that I should have gotten, that's not a great yield, but I'm about at the northern edge of where you could even consider growing cotton, and plus I'm not a good farmer, so I was proud of my yield. I only needed probably 1 or 2 pounds actually to make the potholder, but I was trying to avoid not having enough.
And then and then like you made thread. You actually spun into thread, cotton
Yeah, so
thread.
actually spinning is the one thing that I have to admit I gave up on. I tried spinning and I tried and I tried, and I finally had to get, basically a nice woman to do it for me because
Uh-huh.
I just couldn't learn. It's hard. I mean, spinning cotton is actually quite difficult to do. It's much harder than spinning wool, for example, because the fibers are a lot shorter.
Shorter, right,
Um,
right.
so not that I know how to spin wool either.
And how many hours would it take to spin the threads that you needed?
A lot. I mean, it's very slow. So actually, the whole reason that I got into having a laser cutter and using Libra Cad and making acrylic models was because I started working on this book about mechanical devices, locks and clocks and scales and things like that. And it's basic property of most mechanical devices that you can't really understand them by looking at them. They're made of metal and they're opaque and they're complicated. They have all kinds of stuff hanging off that's peripheral. And so normally what people do is they draw a diagram, a cutaway view or some kind of 2D, diagram that simplifies and abstracts the mechanism out. But I suck at Illustrator, and my books historically have always been photo books, like pictures of real stuff. And so I thought I want to figure out how can I make physical objects that I can photograph, but that have the same sort of explanatory power as a diagram would have. And what I came up with after some, consideration of options is a laser cut thing. Design something like I would draw if I were going to draw it, but then actually make it and then photograph the physical object. And so in the book, there are a bunch of different places where there are things that look a lot like diagrams, but actually they're not. They're actually physical objects. And having done that, I very quickly realized that although this is going to work for the book, the objects themselves are way cooler than the pictures of the objects can ever be, because the object itself, you can actually pick it up. And, there's like a lock that explains how a pin tumbler lock works. Well, that's a real physical lock. You can actually stick a key in it and it works. And, steam engines, the timing of the valves in a steam engine. I didn't really understand that until I had a model to play with. So, I thought I really ought to, make these models available to people so that they can also play with them and have the sort of richer experience of a hands-on thing rather than just pictures in the book. But it started with the book.
Right. But the book continues with a lot of other transparent machines that you've collected over the years, showing how they work inside, or giving you a little hint of that.
But there's actually a chapter. The first chapter is about transparent things, just stuff you can get that is transparent. Which, the first thing like that I ever saw was a slimline telephone back, I don't know, probably in the 70s or 80s maybe. That is a very cool, telephone. It's got a transparent case, and you can see all the transistors and the capacitors and stuff in there. And it's very cool. And so I thought, I'll put that in the book. And then I started looking around for what other sorts of things could you get. And I was visiting this friend of mine who's has been in trouble with the law, as they say. And she had this incredible television set. It was like a old school tube TV with a transparent case, and you could see everything inside. And I thought, wow, this is, A, amazing, and B, unexpected that she would have such a high style, thing. But turns out it's a prison TV. And it turns out that there is, in fact, an entire industry of objects, common household objects, radios, hair dryers, shavers, televisions, headphones, earbuds, you name it. If you can imagine being in a low security prison and you're allowed to have this object, you can buy it with a clear case because they don't want you to be able to hide anything inside. It's, to avoid contraband being smuggled in.
Right.
So there's actually an astonishing variety of things that you can get with clear cases.
Right. And what they allow is they give you, again, a little glimpse of how things actually work inside, which is sort of the theme of your book about how things work, how
great.
Ordinary, they're usually hidden behind some opaque plastic, but they all have mechanical logic. They have parts that move, even simple things. And so this book is, you're kind of going through clocks and pendulums, all kinds of things that we don't normally get to see. You're kind of explaining with fantastic photographic illustrations how they actually work.
Yeah, I mean, I love machines. I wrote a bunch of books about chemistry, but I've really loved machines. Probably say longer than I've been seriously interested in chemistry topics, because that's what I was doing as a kid, is taking stuff apart, obviously, and not much of it made it back together again. But it's very educational to take that stuff apart.
Right.
Yeah.
Most things that are made can be taken apart pretty easily, because they've been put together in a certain sequence.
Putting them back together again when you're a kid.
And getting them to work again,
That's hard.
It is tough. Well, Theo, thank you for this great time together. Again, your book is called How Things Work, The Inner Life of Everyday Machines. I know you're saying you're working on another book about tools, not just machines, but maybe tools. We look forward to that. And your past books on the elements were fantastic as well. So thank you again for this time. You're always full of tools that we don't know, I've never even heard about. So thank you.
Cool. Well, thanks for having me on.
Hey everybody, it's your host Mark, and I wanted to thank you for listening to the Cool Tools Show. And I also wanted to let you know that we've got a lot more going on at Cool Tools than just this podcast. We also have the Cool Tools website, which has a new tool review every day, and you can get there by going to cool-tools.org. We also have 4 different newsletters that you can subscribe to, and you can subscribe to those from the Cool Tools page. We have this podcast that you're listening to right now. We also have a YouTube channel where we review tools. Check that YouTube channel out by going to youtube.com/cooltools. And one of the things I'd like to ask you is, if you're really enjoying everything that we are producing, go to our Patreon page and support us there. You can sign up and give us as little as $1 a month, and that would mean a lot to us. The money that we get from Patreon goes towards a lot of things. We transcribe our podcast interviews so that you can read them online. We pay for editing of our podcasts and for our videos. We pay our contributors. We have video production costs. We have equipment costs. We have hosting costs. And the money you give us through Patreon also goes to support Cool Tools Lab. Anything you give is a huge help. And one of the things that we do is, if you are a contributor to Patreon, we'll give you a shout out on air. And so I have a few people here to thank this week. Mark Lyanaj, Micah Gates, Monty Zukowski, Patrick James McNally, Robert Cohen, Scott, Spence Lloyd, Steve Avery, Steve Golden, Steve Levine, Tom Hess, William Phillips, Aaron Nipper, Durab Patel, Glenn Mercer, Jay Walker, Jeff Bonner, Ryan Jarrell, Pat Daly, Patrick Kennedy, Troy Wallet, Mike Camerate, Nicole Harkin, Tim Youssef, Scott Reed. Thanks all of you for supporting Cool Tools. And if you would like to have a shout out, go over to the Patreon page and sign up. And thanks for listening to the Cool Tools podcast. We'll see you next week.